In this, let us quickly go through the question. See, the question is like this: a causal LTI system is described by the difference equation. The difference equation is y of n is equal to y of n minus 1 plus y of n minus 2 plus x of n minus 1. Find the system function h of z. So h of z is the ratio of y of z by x of z. So we need to find that. Then plot the poles and zeros and indicate the region of convergence. Okay, so region of convergence we need to indicate, and also determine the impulse response of the system. Okay, so ROC we need to determine, then impulse response means h of n. So we need to find h of z, then we need to find what are the poles and zeros, indicate the ROC, and determine what is h of n. Okay. So question here is y of n is equal to y of n minus 1 plus y of n minus 2 plus x of n minus 1. This is the difference equation given. For this, we need to find h of z, poles and zeros, ROC, and h of n. Okay, so usually what we do, we know the equation for h of z as h of z is equal to y of z by x of z. That means we need to take the z transform of the given difference equation. So this is y of z is equal to z inverse into y of z plus z to the power minus 2 y of z plus z to the power minus 1 x of z. This you know. Okay. This is the difference equation. Now y of z minus z inverse y of z minus z to the power minus 2y of z is equal to z inverse x of z. This is the answer you will get when you take y of z terms on the left hand side. So let me consider y of z as common. So if I take that as common, what I will get? 1 minus z inverse minus z to the power minus 2 equal to z inverse x of z. Okay. Now y of z divided by x of z is equal to z inverse divided by 1 minus z inverse minus z inverse whole square. This is our system response h of z. Okay, if I let us consider z inverse is here, I will take z to the power minus 2 as common. What will happen? Z square minus z minus 1. So this, let me write another step for that. minus 2, and if it goes to the numerator, what will happen? This will go to the numerator, means it is z square. So this square and this will cancel out and we will get z divided by z square minus z minus 1. Both the forms are equally correct, this one as well as this one. Okay, since we want x of z, we are writing in this form. Okay, now this is in the form of ax square plus bx plus c, correct? So you need to find out the roots for this equation. So when you find out the roots, you will get that the roots are z plus point z plus 0.62 and z minus 1.62. So actually it is, let me write it properly. Z plus 0.62 and z minus 1.62. Okay, in the notes I have wrongly given poles as z is equal to 0.62. It should be minus here and it should be plus. Similarly, this ROC diagram, whatever I have given in the notes is wrong. Please note that. So this is the equation we are going to get, right? By that, let me draw here. This is h of z. First point is cleared. Now poles are the values of z, correct? Values of z which make the h of z infinity. Okay, so what are the values? If you substitute z is equal to minus 0.62, this is one pole which will make the h of z as infinity. Similarly, z is equal to minus 1.62, it will also make h of z as infinity. So these are the poles. Now when it comes to zeros, it is obviously there is only one z is there. So this z is equal to 0. If you substitute, h of z will be 0 by anything 0. So this is a 0 and these two are poles. Since we have plus here, we need to equate it to 0. It will become z is equal to minus 0.62. This will become z minus 1.62 is equal to, okay, this is 1.62 plus 1.62. In the notes I have given it as plus 0.62 and minus 1.62. That is wrong. Please make a change in your notes as well. Now let us write the ROC. ROC is 1 0 is here and there is a pole at minus 0.62. Say this is minus 0.62. There is another pole at 1.62. This is 1.62. And since given system is a causal system, given system is mentioned as a causal system, ROC is outside outermost pole. Causal system anta ಕೊಟ್ಟಿರೋದ್ರಿಂದ always ROC is outside outermost pole. ಯಾವುದು ಇದರಲ್ಲಿ outside outermost pole ಯಾವುದು? Z is equal to 1.62 is the outermost pole. So ROC, is Z must be greater than 1.62. Is that clear? So this is the ROC of the given sequence. So first part H of Z, second poles and zeros, and then ROC. Last part we have to find out H of n. So ಈಗ ಕೊಟ್ಟಿರೋ ಈಕ್ವೇಶನ್ ಪ್ರಾಡಕ್ಟ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಇದೆ. ಸೊ ಪಾರ್ಷಿಯಲ್ ಫ್ರಾಕ್ಷನ್ಸ್ ಇಂದ ಅದನ್ನ ಸಾಲ್ವ್ ಮಾಡಬಹುದು. That's why we take partial fractions now. Consider H of Z is equal to Z divided by Z plus 0.62 Z minus 1.62. This is equal to A1 divided by Z plus 0.62 plus A2 divided by Z minus 1.62. Okay, this is the Z transform form. In the notes I might have used Z inverse. That is, here you can see both the forms are correct only. No need to worry about that. Whatever is easy for you, you can use that. I have taken Z as common. If I take Z as common here, I will get a different answer. That's why using that method we have written. Okay, ಈ ಕ್ವಶನ್ ಯಾವ ರೀತಿ ಬರೀಬಹುದು? Z inverse divided by 1 plus 0.62 Z inverse 1 minus 1.62 Z inverse. Okay, this is equal to A1 divided by 1 plus 0.62 Z inverse plus A2 divided by 1 minus 1.62 Z inverse. ಸೊ ಈ ರೀತಿ ನೀವು ಬರಬಹುದು. ಎರಡು ಈಕ್ವಲ್ ಆಗೇ ಇದೆ, ಎರಡು ಸೇಮ್ ಅಂತ ಅರ್ಥ. ಸೊ ಇಲ್ಲಿ Z ಇನ್ವರ್ಸ್ ಇರುತ್ತೆ, ನೀವು ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದಾಗ, ಕ್ರಾಸ್ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದಾಗ ಇಲ್ಲಿ Z ಇನ್ವರ್ಸ್ ಇರುತ್ತೆ, ಇಲ್ಲಾದ್ರೆ Z ಇರುತ್ತೆ, ಅಷ್ಟೇ ಡಿಫರೆನ್ಸ್. ಓಕೆ, ಸೊ ದಿಸ್ ಈಸ್ ವಾಟ್ ಐ ಹ್ಯಾವ್ ಗಿವನ್ ಇನ್ ದ ನೋಟ್ಸ್. Now when you solve this problem, you will get, say, let me solve this one. So you know that Z is equal to A1 into Z minus 1.62 plus A2 into Z plus 0.62. Okay, let Z is equal to 1. 1.62. So if we substitute Z is equal to 1.62, what will get? 1.62 is equal to A1 into 0, correct? 1.62 minus 1.62 is 0, plus A2 1.62 plus 0.62, correct? So A2 into, that is 6.62 and 0.62 is 2.24 and this is 1.62. So with this we will get A2 as 0.45. A2 is equal to 1.62 divided by 2.24 is equal to 0.45. Similarly, if you put Z is equal to minus 0.62, then you will get minus 0.45. So A1 will be minus 0.45 for Z is equal to minus 0.62. Okay. So if you put these values, you will get A1 and A2. Now you can rewrite the H of Z. H of Z is equal to minus 0.45 divided by Z plus 0.62 plus 0.45 divided by Z minus 1.62. So now directly from the Z transform pairs table we can apply inverse Z transform, where H of Z will become H of n minus 0.45 is a constant which will be outside, then 0.62 minus 0.62 to the power n u of n. Why I am taking u of n? Because ROC is right sided and it is greater than 1.62. Obviously it will be greater than minus 0.62 also. So we will write this as 0.45 plus 1.62 to the power n u of n. So this is our system's impulse response. Okay, we have calculated system's impulse response. We have calculated the ROC. We have calculated poles and zeros locations and H of Z transfer function. This is the transfer function. These are poles and zeros and this is ROC. And for those who have joined just now, for them, see here this ROC whatever I have given is wrong, because here the pole should be minus and here it should be plus, and it will become like minus 0.62 and plus 1.62. Okay, so this is wrong. Okay, ROC is outside the outermost pole. Here I have indicated it. That is correct. ROC is correct, but the location of poles is reversed. Okay, please make a note of it. So this is the answer what we have got. System is causal. ಅದಕ್ಕೆ ನಾವು u of n ಅಂತ ತಗೊಂಡಿರೋದು. ಕ್ವೆಶ್ಚನ್ ಅಲ್ಲೇ ಕೊಟ್ಟಾಗಿದೆ ಸಿಸ್ಟಮ್ ಇಸ್ ಕಾಸಲ್ ಅಂತ. ಕಾಸಲ್ LTI ಸಿಸ್ಟಮ್ ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. ಕಾಸಲ್ ಅಂತ ಕೊಟ್ಟಿರೋದ್ರಿಂದ ರೈಟ್ ಸೈಡೆಡ್ ಸೀಕ್ವೆನ್ಸ್ ಅಂತ ಬರ್ಕೊಂಡಿರೋದು. ROC is outside outermost pole. That is 1.62 is the outermost pole. ಯಾವುದು ಲಾರ್ಜರ್ ವ್ಯಾಲ್ಯೂ ಇದೆ ಅದು outermost pole ಅಂತ ಕರೆಸ್ಕೊಳ್ಳುತ್ತೆ. Now coming to unilateral transform. Okay, before going for the actual problem, I want to explain you regarding the unilateral problem, unilateral Z transform. Okay, so let me stop here.